Greetings all. Myself Sapna Jain. I am Assistant Professor in Department of Computer Science in ABES Engineering College. Today we will be looking into K nearest neighbor. This is machine learning algorithm which comes under supervised learning. It is basically a classifier, that is classification algorithm. Let's see some key points first. It uses proximity, that is nearness, to classify or predict a new data point in a particular class. It works on the assumption that similar points can be found near one another. The next important point is criteria that is used in this algorithm for the classification, and it is majority voting. Let us understand what do you mean by majority voting. Here you can see an example. Look at the first quadrant in which you have the data of tree type, which is depicted in three colors. One is lime green or yellow, another is green, and another is your orange. Now we are representing three different classes in the three different colors. These are the data points of these three different classes. Now we have one new data point which is represented in gray color. It has arrived and we have to classify it in either of the three classes. According to KNN, as I told you, it assumes that all the similar points are present nearby. So what we used to do is, from this gray point, we start calculating the distances between the gray point and all the other points. Then, after calculating the distance, we make them in a sorted list. We arrange them in a sorted list. As you can see, in the diagram which is mentioned by number 1, you can see that the distance between the points yellow and gray is 2.1, 2.4. It is 3.1, it is 4.5. Now, after arranging all this data in sorted order, I have considered here two or top 4 points only. So after arranging this, we can see that gray to yellow distance is 2.1. Another gray to yellow distance is 2.4. That is second nearest neighbor. First nearest neighbor is first yellow point with distance 2.1 units. The second nearest neighbor is having distance 2.4 units. Similarly, third nearest neighbor is having distance 3.1 units. After this arrangement, we will vote on the predicted class label. That means we will count the number of nearest neighbors and categorize them in their classes. Like here we can see the two data points that are nearest to gray data point belongs to yellow class. So the class is yellow and the number of votes are 2. And the class is green, number of vote is 1. The class is orange and number of vote is again 1. So according to majority voting rule, the data point, gray data point, will belong to the class which is having majority of votes. So we can say according to KNN, gray data point belongs to yellow class. This is the source from which I have taken this diagram. Now this is the concept on which your KNN works. Now the question is how we are defining that we will consider how many points. This is number K. And the next is, what is the formula to evaluate or to calculate the distance between your new data point and the present data points. So before going on to the mathematical detail, just let's have a look onto the algorithm. This is algorithm, very simple. I have taken it in a simple pseudocode. Step 1 is select the number k of the neighbors. That means from how many neighbors you want to decide the class. That means majority voting rule is applicable on how many neighbors. That number you have to decide. The accuracy of KNN algorithm when you are doing implementation depends highly on this k. It should be optimal, neither too low, neither too high. Now, step number 2 is after selecting number of neighbors, you have to calculate the distance between those number of neighbors and the new data point. This is done by various mathematical methods or formulas or models. I have mentioned here Euclidean distance because it is taken generally. Now the step 3 is after calculating the distance, you will take the k nearest neighbor as per calculated Euclidean distance, and among these k neighbors, you will count the number of data points in each category. And the category which is having the maximum majority vote will take the new data point. And then our model is ready. This method is followed and repeated for each and every new data point that comes. Now let's have a look on the mathematical aspect, that is your Euclid, that is your mathematical distance that on which our KNN is based. As I told you, there are different methods available in your statistics which govern it. Here we are discussing 3 methods which are generally present in the implementation, that is the machine learning library, scikit. Now, first one is your Euclidean distance. Euclidean distance formula is also mentioned here. It is calculated as the square root of the sum of squared differences between new point and existing point. Then Manhattan distance, it is similar to Euclidean. The difference is it is not taking square and it is not taking the square root of the square. So this is the distance between real vectors using the sum of their absolute difference. Next is your Hamming distance, the third point. Now this Hamming distance is it is used for categorical variables. If the value x and value y are same, the distance d will be equals to 0. Otherwise, we take it as 1. So whenever we have data which is having categorical values, then we go ahead with Hamming distance. Else we used to go ahead with Euclidean or Manhattan distance. Now let's have a look at the implementation aspect. We have seen what is KNN and what is the key points, what is concept behind and the algorithm and then the distance formulas. Let me discuss the implementation part. This is Jupyter Notebook and I am using Python for the implementation. Here you can see the first in any machine learning implementation, model implementation, the first and foremost part is just import the necessary modules, libraries that you will be using in your implementation. Next is load your data. For machine learning algorithm, we need data. That is prime requirement. So first step is import necessary module. I am highlighting the respective code. In this, I have imported sklearn library. From sklearn library, I am taking neighbors module from which I am taking k neighbors classifier class. Now, from sklearn, I am taking model selection module and I am importing train test split class. From sklearn library, I am importing datasets module, and from datasets module, I am importing load iris class. Now, next step is, after loading the necessary module, the next step is load data. This single line is loading iris dataset in the memory. We have iris dataset available on uh, various online platforms such as your Kaggle or UCI or many other websites available nowadays. And also some data sets which are frequently used for machine learning model implementation, testing purpose or training purpose. We used to keep them in your libraries as well. So iris dataset is also present in sklearn library, as you can see here. So I have taken it from sklearn library datasets, and next I have created one iris data object of this load iris class. From this, what will happen? It will load the iris dataset into this object. Let me run it first. Now, if you want to see what is the output of this, what is present in iris data, we can check it out. Let me print it. You can see this is the data set that has been loaded into this object. As you might know, iris is a data set of iris flower. It has three categories of flowers. It shows your petal length, petal width, sepal length, and sepal width in dataset. And the fifth column is your category, in which category this particular falls, as you can see here. So this data set has been categorized in this particular sklearn library into two parts. One is your target array and another is your data array. So iris data object is having two two sub objects, you can say. One is your data having sepal length, sepal width, petal length, and petal width of each iris flower. And another is your target, in which you have the category, which is mentioned as 0, 1, and 2. This is machine learning algorithm. Everything can be done only on numbers. So we used to convert the categories into numbers. So this is the representation. This I have shown you how the data has been taken into iris data object. Okay. Now, once I have taken the data into this, the next step is to create your target and your feature arrays. So once you are done with this, I will take the data, that is feature data, into your X, and I will take the target data into Y. So here you can see it is very simple. In iris data, we have data part. So I have taken this part into X and target part into Y variable. So I have taken two variables in which I have copied the data from this object. After having this, the next step is splitting into training and test set. Once you have the data, complete data set into X and Y. Iris data set dimension is 150 cross pi, that is 150 rows and 5 columns. 4 columns I have taken in X with 150 rows, and 150 rows with 1 column I have taken in Y. If you want, you can check the size, the shape of X and Y, which will clarify this thing to you. Let me show it to you. Just a minute. Okay, it will fine. Yes. So